scientists here, we have not shown any images so far. So
Yes.
do we have any images of Venus?
Yeah, absolutely. So we were talking about the phases of Venus earlier. We have this really nice figure of how the phases of Venus look.
Ooh, look at
Yeah.
that.
So is this what you saw when as a child when you were
That's
doing Venus
exactly it.
PhD?
Yes. Yeah, I actually made this image.
I am. This is me in the image. This one's
Yeah,
me. I
that's
am.
right.
This is a picture of
That's me.
me.
Me as a 7-year-old. Yeah, I think I saw something similar to one of these middle rows actually.
Okay,
Yeah, it's just incredible.
that's that's amazing. Seeing her as a crescent, like that's wild.
Yeah, I think it was super duper. Yeah, it's just the angle of the Earth Venus Sun system must have been just right to give it one of those lovely crescents.
So I've
Which,
got a strange question here.
okay.
How do they capture an image like this in the bottom right? Because that looks almost like a new moon, which I know is when like the object is in between us and the sun. But if the object is between us and the sun, there's no way you'd be able to look at Venus with a telescope.
No,
So
that's
is it
true.
like a transit or from a spacecraft?
That is a great question. Well, again, even if it was a transit, you'd have the background sun. So unless they sort of photoshopped it or edited it out with or used a fancy coronagraph, I suspect what it is maybe the sun is almost in line, maybe 5 degrees off or something like that, and what you're just seeing is the atmosphere of Venus being backlit, and there's just a very uniform distribution of light.
I
But you're right;
see.
it does look incredibly uniform.
You ever see
Don't,
the you ever see the YouTube videos where it's like some horrible like some tragic horrible explosion or something that seems to be causing a ton of damage, but somehow like the cameraman is like unharmed. I'd like to know how the cameraman did this shot, it's floating out in
yeah,
space.
I don't know. That is a really good question. I don't know is the answer.
But it is Venus is absolutely stunning. Being able to see the faces like that.
Oh,
So
absolutely, it's phenomenal.
how come we don't see pictures like this for Jupiter and stuff? Like I've only ever seen this for Venus and Mercury.
Well, so I think the obvious answer has to be that we're looking inside our orbit, and so we see the Mercury and Venus that they both show phases. You're seeing them as they rotate around the sun, and you're seeing the angle change. With Jupiter being an exterior planet to the Earth, there you always see essentially a full face illuminated. But don't forget, Earth is also moving very, very quickly. And so we never essentially get in position where we could see a phase. So I think you're always seeing effectively a full face of the outer planets.
That's really cool.
Yeah.
So if that's the case, then does Venus have a meaningful opposition like Jupiter and other planets do, where there's like a point where they look brightest because they're on the opposite side of the sun?
Yes. I think the answer to that is definitely yes, because obviously that is where you're seeing the fullest illumination. But they're also then farthest away from the Earth because essentially they're on the far side of the sun. Maybe not directly in line, obviously, because that would effectively be an eclipse. But they're probably just offset by whatever 10 degrees.
Or
15
maybe
degrees.
the tilt of their axis.
Well, no, but don't forget the tilt that we mentioned earlier on that the Venus actually lies in the ecliptic plane as we do. So
All right. Oh well, so opposition wouldn't be other side of this. It wouldn't be covered by sun because opposition is when it goes sun, Earth, and then planet. So I guess Venus can never have
uh,
an opposition. I guess.
well, I was thinking of inferior conjunction. So
Yeah, I
inferior
think conjunction, but opposition is
conjunction.
when the
Okay.
planet looks brightest.
Well, but
Right.
that would have to be on. That would have to be at the far side, right? When if we're
It,
here and the sun's here, it'd have to be the other side for us to see
uh,
the full disk.
let me check. I think conjunction is when it's on the other side, and then opposition is when it's on the same side, because then it's fully illuminated by the sun with nothing in the way.
Uh, oh no, you're right. You're right. You're right. Yep. Yep. I got confused by that. Yep. You're right. I apologize.
It's
So
okay.
yeah.
There's
So
only
what?
1,400 different terms
I know. I know.
for every
It's been a
goddamn
lot.
angle of a planet's orbit.
I know. There's so many. Yeah. No. So you're 100% right. I apologize. So yeah, those two. Well, conjunction opposition. Well, hang on. We can't. No, in that case, I don't understand. We can't. Venus can't have an opposition because it's
That's what I'm
inside the
thinking.
Earth's.
I don't think Venus can have an opposition at
Oh
all
no.
because, like,
Okay, that's why I was
yeah,
confused. There's no opposition.
Yeah,
Yes,
but
because if you
Venus
look
does
at
have it's the inferior. I think this is what you're talking about. The inferior conjunction is the
yes,
equivalent when Venus looks the largest because it's closest. But
yeah,
at an
but it's
inferior
back illuminated.
conjunction, that's exactly what I was going to say. At inferior conjunction, when it's closest, it's going to be it'll be as close to the sun as it could be. So
Yes, but you don't see the illuminated side at that point. So
right.
you see the full face of it here at sort of superior conjunction when it's round the back, or at least conjunction, as if it's superior, you can't see it. But
Yep.
you see the full face of Venus, but it's much farther away from the Earth because
Right.
depending on the Earth's position, in fact, it must be at least 1.7 AU. Yeah, about 1.7 AU. So that's a really nice image, actually. So
I
one can
actually really
imagine
like
with
this
you.
diagram because it explains what we were talking about too with the phases. Why you can only see it for the interior. Like you can from the Earth, you can clearly see the
Yes,
phase, but then for the
that's right.
external ones, you can never see the black part of the planet, like the planet part of the planet in shadow.
Well, you can actually at greatest of eastern and western elongation because you see a half phase
Sorry
from the.
for the interior planets, but I'm talking about for the exterior planets.
Oh yeah, correct. That's
Yeah.
exactly right. That's exactly right. Which is what we said, right, when we talked
Right.
about it. It's the fact that when you're on the outside, you essentially see the full disk of the planet.
Yeah.
Yeah,
But I
you
think
don't see the.
this just visualizes what you said really nicely.
Yeah,
Because it's
absolutely. Yeah.
yeah.
Yep. Yeah, that's a nice. I'm glad you pulled that up. It's complicated. Planetary dynamics
It is.
are not simple things to envisage in your head.
So I know for like this elongation term. So what does this look like in the sky when something's at its greatest elongation?
That's a great question for the inferior planets, which we're talking about Venus here. That means it's the farthest the planet can appear from the sun. Now, for Venus, that turns out to be about, I can't remember the exact number, but it's about 45 degrees, which is why you never see Venus in the middle of the night sky or the middle of the daytime sky for that matter. You always see it within about 45 degrees or less of either the setting sun or the rising sun. Because, of course, as you look in from the Earth inward toward the inner solar system, you're looking more or less, as this diagram shows very nicely, the maximum position of the inner planet from the sun. And you can see here, this actually looks not far off the Venusian system. It looks to be about, I don't know, it does look to be
About half the distance.
well, 35, 40 degrees.
Yep.
Yeah.
That's
Yeah, so
super cool. Sorry.
Yeah, well, this diagram actually explains really nicely why people get Jupiter and Venus confused, and it's almost impossible for that to happen. Because if you see Jupiter, which is a bright object in the middle of the night sky, and my children have done this, they've looked up and said, "Oh, is that Venus?" And I'll say, "Well, can it be Venus? Where's the sun?" They say, "Well, the sun is set." So I'll say, "Well, can that be Venus?" And they'll say, "No, because Venus is close to the sun." Children visualize this really well, actually. And so
Maybe your children, because your children are geniuses.
well, I wouldn't go that far, but they make they make wrong inferences just like the rest of us. But they're pretty sharp at this stuff. We lived in Hawaii, and Benjamin was about, I don't know, he was about 2 or something, and he was always very talkative and very bright. We would drive home, and I would say, "So, what's that over there?" And he'd say, "It's the moon." I'd say, "Well, what phase is it?" And he'd say, "Well, it's about half moon today." I said, "Yep." And then we'd see Venus. I say, "Well, which planet is that?" And he'd say, "Well, it's either Venus or Jupiter." I'd say, "Why is it Venus or Jupiter?" I mean, bear in mind he was 2, right?
That's
But I used to
amazing.
talk to him about
2 years
I
old.
used to talk to him. Yeah, but I used to talk to him about this stuff all the time. And I'd say, "Well, it can only be Jupiter or Venus because it's really bright and it's sunset, And he said, and I said, "Could it be Jupiter if it's near the sun?" And he said, "Yes." I said, "Well, it could be Venus too, right? How do you know?" And he said, "Well, I don't know." I said, "Well, I don't know either without a telescope." And so, I teach him those kind of things. But in the middle of the night, or if he was up, if we were out, and occasionally I would take him to see the stars at night. I'd say, that thing up there, is that Jupiter or Venus? And he'd say, "Well, it's either Jupiter or Venus. I don't know which without a telescope." I say, "But where's Venus? Has to be close to the sun, right?" And he'd say, "Oh, right. So it has to be Jupiter." So yeah, even as a
That's
2-year-old,
amazing.
yeah, he was phenomenal with that. Like the
Your kids,
basics of.
man, they're so lucky to have you.
Well, we used to talk about this stuff, but
I do get asked pretty frequently. Like someone will see like either Venus or Jupiter, especially because they're so bright, and they're like, what am I seeing? And oftentimes people will be like, I'll just tell them if it's Venus or Jupiter, and they'll be like, how can you tell the difference? And I'm
I
like,
can tell.
I think the most people, a lot of people haven't seen Venus because you have to get up kind of early to see it. Um, uh, or be out right around sunset when it's on the
That's right.
other side.
That's right.
But a lot of people like see it and don't know what it is. And so I find that it's like I find that people think Venus is Jupiter. Oh, sorry, I find that people think Jupiter is Venus a lot of the time until they've actually seen Venus, and then you cannot mistake it. Like it's
That's right. That's
Venus
right.
is stupidly bright. Like, and
It's
it's
very bright.
huge. Like you can almost feel like you can see the surface. Like that's how big it looks. Like it's like it like you can almost see like a disc with your eye. Like it looks so
Yeah.
ridiculously bright.
Well, I think out in the desert or in dark sky areas, I think Venus casts a shadow, and I don't think Jupiter does, at least not very well.
I
So
would be very surprised if Jupiter casts a shadow.
yeah, I think it subtends quite a small angle on the sky, where Venus is a bit bigger, but it's just much brighter. And so yeah, I've seen my own Venusian shadow on the Earth. It's actually lovely. It's sort of
That's
what the heck?
magical.
Oh, it's amazing. It's just beautiful to see, actually. So I think we have another. We should say this image.
Yeah.
I actually love this image. And we have another image to see, and it's actually the surface